This is an exact differential equation that in order to solve, again, we have to follow these steps. If you have followed my video by now, I believe you will be able to solve equations like this. The only challenging thing will be the integral and differential formulas that you have to know. Sometimes in an exact differential equation, if we take a factor out of the equation, that equation might no longer be an exact differential equation. Let's say, for example, in this equation that we know it is the exact differential equation, if we go ahead and factor out y to power minus 2, let's say this will be y to power minus 2 multiplied by y to power minus 2 have to be multiplied by y squared in order to be 1. Y to power minus 2 times y squared is y to power minus 2 plus 2, y to power 0, which is 1, plus 2x y, so we have to have y minus power 2 times y is equal to y to power minus 2 plus 1, which is y to power minus 1. The x minus x squared dy equal to 0. So now in this equation, this portion is no longer an exact differential equation. So if I was your teacher and I had assigned something like this for homework, for test, I would make a problem like this, ask you, we know that this have to be multiplied by y to power minus 2 in order for us to have an exact differential equation. So I would make a problem like y to power n and ask you for what value of n this equation will be an exact differential equation, and after you find the exact differential equation, solve it for me. So that would be a good problem for test. So we know that the value of n must be equal to minus 2 in order for this equation to be an exact differential equation. So let's go ahead and find n. Let's go ahead and multiply n inside the equation. So we are going to have y to power n plus 2 plus 2x y to power n plus 1 dx minus x squared y to power n dy equal to 0. So this is our n and this is our n. In order for us to have exact differential equation, the partial derivative of n with respect to y must be equal to the partial derivative of n with respect to x. So partial derivative of n with respect to y will be n plus 2 multiplied by y to power n plus 2 minus 1 plus 2x multiplied by n plus 1 y to power n plus 1 minus 1 equal to partial derivative of n with respect to x, which is equal to minus 2x y to power n. So in order for our equation to be an exact differential equation, partial derivative of n with respect to y must be equal to partial derivative of n with respect to x. So here, 2 minus 1 is 1, so we are going to have n plus 2 times y to power n plus 2x times n plus 1 to power y to power n, 1 minus 1 is 0, equal to minus 2x y to power n. So let's divide both sides of equation by y to power, okay, sorry, this is going to be n plus 1. Plus 2 minus 1 is plus 1. So let's rewrite this as n plus 2 y to power n multiplied by y plus 2x times n plus 1 y to power n equal to minus 2x y to power n. So let's divide both sides of equation by y to power n. So y to power n will cancel on both sides. So we are going to have n plus 2 multiplied by y plus 2x multiplied by n plus 1, and let's bring minus 2x to the left side, will be plus 2x equal to 0. So in here, let's go ahead and factor these 2x. We are going to have n plus 2y plus 2x multiplied by n plus 1 plus 1 equal to 0. So this is going to be n plus 2y plus 2x multiplied by n plus 2 equal to 0. So if we factor out n plus 2, we are going to have n plus 2 multiplied by y plus 2x equal to 0. So for this term to be equal to 0, n plus 2 must be equal to 0. So from here we can solve for n must be equal to minus 2. So n must be equal to minus 2 in order for this equation to be exact differential equation. So if we multiply y to power minus 2, we get in that problem. This will be a good kind of problem for a test that will show a teacher who have really understood the subject. Now, again, we can use this step and solve the problem, and I'll let you do that. See you.